Hi guys. First of all, apologies for all of the confusion over the test on Friday. You should not have been able to see the answers after you took the test, but for some reason you were able to. And in the course of trying to go through the data, somehow scores got reset. So what we're going to do instead to try to resolve this is go through the test from Friday, going through the answers, showing you what they are, showing you what resources you need to solve them, and then Tuesday in class actually taking it again. It'll be a very similar type of test, just with different substances, so please make sure you are doing that on Tuesday. In the future, I'm trying to learn Google Classroom just like some of you might be. I imagine most of you are familiar with it, but I'm trying to learn how to do it. If something seems fishy or it seems like I've done something I shouldn't have done, clicked the wrong box, please let me know. I'm not perfect at this, so I'm trying to learn it along as I'm doing it. So in any case, let's go ahead and start looking at some of the answers here. So this is from the test on Friday. The first one says, which of the following best represents a synthesis reaction? You might remember from your notes before break, synthesis reaction is when you have two things becoming one thing. And so in generic form here, we're looking for two things on the left side, and that looks like this one can't be correct. And the other ones here, two things becoming one thing, well, that one checks off. This is two things becoming two things. That's two things becoming two things, so the answer here should have been that one. Okay, for number 2, a reaction where one element displaces another is better known as a... Okay, so this is where you have an element plus some compound yielding a new compound plus a new element. Okay, so A and B are switching places. It displaces it, right? It's a replacement reaction. Well, since this is an element here, not a compound, this is not a double replacement. This is a single replacement. Okay. Moving on to number 3, what must always be present in a reactant, as a reactant in a combustion reaction? For you to combust something, it's some substance plus oxygen. Okay, it's always got to have O2. All right, that's just by definition of what this is, and that should be in your notes. So oxygen you have to have in order to have stuff combust. Number 4, which of the following is not a type of single displacement reaction? And this comes from your notes on this section for single replacements. You can have a metal replacing another metal. That'll work. You can have metal replacing hydrogen. That'll work. You can have a non-metal displacing another non-metal. And the only one that doesn't exist is this. So an example of all of these things here, something like aluminum plus copper 2 nitrate. Okay, that aluminum will replace this copper, right? That's a metal replacing a metal. The second example here, you could have something like zinc plus HCl, hydrochloric acid, where the zinc is going to replace the hydrogen and the hydrogen becomes the element. Down below here would be something like if you had, I don't know, MgBr2 plus chlorine gas. Now you're looking at the element here, chlorine replacing the bromine, but those are both non-metals. Chlorine's a gas, bromine's a liquid, so those are non-metals. So all of those have examples of single replacement reactions. This one does not. Okay, question 5. Classifying the following chemical reaction. You've got 2NaN3 going into Na plus N2. Here you have one thing breaking apart into two or more things, right? You got breaking apart into sodium and nitrogen gas. That is going to be an example of decomposition, something breaking apart. So that would be your answer there for that one. Number 6, using the reactivity series, which metal, if present in a single displacement reaction, will always displace another metal? So this is looking at that activity series that I handed to you in class. You should have it. It should be on a purple sheet also with the solubility rules. It's a list, okay, and it's got a list of metals on the top of which is lithium, and I can't remember exactly what's on the bottom. It's either like gold or platinum or something like that. In any case, remember, it works by if the element is above the one that's in the compound, it does replace it. Well, the one that's on the top of the list here will always replace stuff. So that's going to be lithium is the answer there for that one. Okay, it's on the top of that activity series. Okay, question 7, classify the following reaction, Mg plus O2 giving us MgO. Well, here you have two things becoming one thing, so that's an example of it being synthesis. You also have oxygen as a reactant, which means that this is also combustion. It's combustion of magnesium or synthesis of magnesium oxide. So the two correct answers here are this is combustion and synthesis, the first two options. Number 8, a precipitate is the result of which type of reaction? This is, again, coming straight out of your notes. This is where you have one substance, one compound plus another compound giving you, say, AY, which is a solid, and BX, which is aqueous. The only way this happens is if you have two compounds here, which means this must be a double replacement, okay, or double displacement, same terminology here. So that would be your answer there. Okay, question 9, predict the products of this reaction. You've got some carbon, hydrogen, and oxygen-based compound plus O2. This right here is the key to unlocking what's going to happen. That's telling you that this is going to be a combustion reaction. And since our compound over here has carbon, hydrogen in it, but has both of them, C and H in it, that means we're going to get both combustion products, CO2 and H2O, and they should both be gases. Well, this one should be a gas, but that's okay. This would be the only option here that looks like the correct answer, CO2 and H2O. Okay. Question 10, predict the following here. Well, you've got an element plus a compound, and the only thing that looks like this is going to be is a single replacement. And so what you need to look at then is the activity series. Again, that purple sheet that we gave you before break, that I gave you before break. And so this time, though, we're looking at the non-metal part of it because we're given fluorine as the element. So fluorine cannot replace copper. Okay, this cannot replace copper. It can't do that. It can replace, though, potentially the other non-metal. That's what that question on the previous one of those previous problems was asking about. So you look to see, is fluorine above bromine in the activity series? The answer is yes, so we should get CuF2, which will be aqueous, plus Br2, which will be a liquid. That's kind of a bad parenthesis there. There we go. And so that answer should be, let's see here, however it was marked, it should be marked as this one, even though technically this one should be a liquid, but that's okay. All right, that's what it should be. All right. Okay, question 11. Predict the following here. You have an element. Whoops, screen's moving around on me. You have an element plus another element. So this is only going to be a synthesis reaction, which means you'll need your ion sheet to figure out what forms here. Aluminum forms a +3 charge. Chlorine forms a chloride ion, which has a -1 charge. So remember, we take the charges and flip them to the other side, right? -1, so the 1 comes down over here. So we end up with AlCl3 is the correct product here. So that should be this answer. Question 12, predict the following. Given this, we got chromium plus HNO3. So we have a metal plus a compound. So we have, again, another element plus a compound. In this case, the chromium and the hydrogen will switch places. We should get hydrogen gas, and then some kind of a chromium nitrate compound, probably chromium 2 nitrate. And our answer here, yep, should be this one right here. Okay. Basically, none of the other answers here are possible. There's only one thing that makes sense, and this is with chromium having a +2 charge. Okay, and how to do question 13. We need to look at the solubility rules. I just copied this off of the internet, but you should have this on that purple sheet that I gave you before break. Basically, what you want to do is go through each of these compounds, break them apart, and see if there are any rules explaining what's going to happen here. Okay, so break them apart into their respective ions. All right, so like this last one, for instance, CAS. There's no rules here for calcium, but there are rules for sulfide ions. It said they are all insoluble except those of sodium, potassium, ammonium, and those of alkaline metals, alkaline earth metals, Mg, Ca, Sr, and Ba. So this one, even though most sulfides are insoluble, this one is soluble. So you would just need to go through and do this to each of the options here and figure out how many of them are actually insoluble in water. Okay, so I'll do another one here for you, SrSO4. There's no strontium rule on the left side, but there is a sulfate rule right here. All sulfates are are soluble except those of barium, lead, calcium, and strontium. So this one is going to be insoluble, so that's going to be a precipitate. Okay, so that's how you use this chart, okay, to go through here. And you can Google the precipitate rules, that's fine if you don't have that purple sheet with you. Okay, so question 14 deals with the image above. It says, which compound is in beaker A? So in order to figure this out, we need to look at what ions there are in beaker A. We have +2 charge ions and -1 charged ions. And so what we need to figure out then is what could be the possible compound here in beaker A. We know it can't be this sodium sulfate. Okay, it can't be that because sodium has a +1 charge. We know it can't be this potassium chloride because that has a +1 charge on it. This lead bromide. Now, lead does have a +2 charge to it, and bromides do have -1. However, this compound is insoluble, which means if it were in water, it'd be sitting down here at the bottom, okay, as a solid, all right? But that's not what's happened. It's dissolved in solution. So we know it can't be that, okay? We know that's not the case. And then what we have left here, well, a perchlorate ion has a -1 charge. That means the iron here is +3. So it's not that one. And then my other option here, CONO32, has got to be the only thing we have left. So we're going to go with that. Okay, so for question 15, it wants to know what is in beaker B. Well, we know that, once again, it's got +2 and -1 charges. So from your ion sheet, we know that that compound can't be correct because the ammonium is +1 and the sulfate is -2. This one could potentially be correct because strontium has a +2 charge and fluoride has -1. This one's definitely not correct because lithium is +1 and nitrate's -1. This one's not correct because magnesium is +2 and carbonate is -2. And this last one, +2 and -1. So this one could also be possible. And from there, we kind of look over here at our solubility rules, or you can Google solubility of these things. SrF2 is pretty much insoluble, and calcium hydroxide is, as it says over here, if we go looking over here, right, hydroxides of barium and calcium are slightly soluble. So this is somewhat soluble, so the only thing that could possibly be, okay, is this guy, all right? And that takes us down to question 16, okay? Predict the precipitate that forms. Well, remember we had CONO32, okay, which is soluble, so aqueous, plus we determined in the next one we have CaOH2, which is aqueous. So my two possible products here are, we could have CO, which again has a +2 charge, mixed with hydroxide, which has a -1 charge, so that compound's formula is COOH2, and then plus, the other option here is calcium mixed with the nitrate, Ca, which has a +2 charge, and nitrate, which has a -1 charge, or -1, calcium's +2. So those are my two options. And then from there, I take a look at, once again, my precipitate rules. Well, all nitrates are soluble always, so this one is going to be aqueous no matter what. And then if we look at hydroxides, all hydroxides are insoluble except for sodium, potassium, barium, and calcium. Okay, so that's telling us that this one is going to be insoluble. That's our solid. That's the precipitate. COOH2 is the correct answer there. Okay, question 17 wants to know which ones are the spectator ions. Remember, those are the ions that start aqueous and end aqueous. Well, everything at the beginning was aqueous. And then what ended up being a solid was the COOH2, right? So that means the other things involved here calcium started as an ion and ended as an ion, and nitrate started as an ion and ended as an ion. So those are spectator ions. So that should be this one right here and that one. Those are the ones that did not do anything. Okay, so that would have been, what, 1 and 3? So that would have been this answer choice, okay, right there. All right. Okay, and the net ionic equation is just taking which ions actually did stuff. Okay, let me get back to my pen here. Which ions actually did stuff in this reaction? Well, the cobalt ion and the hydroxide ion, there's 2 of them, they produce the cobalt-2 hydroxide compound, okay, which was a solid. So my answer here is this guy, okay? All right. And then this question just says, which of the following ions are present in the final beaker after the 2 are mixed? Well, those are the ones that are still ions. Those are the spectator ions. It's basically a different way of asking the same thing as we had before. But we're going to have calcium ions and nitrate ions. Okay, question 20 gets back into stoichiometry, which we haven't seen for a little while. But real quickly, you'll notice that every single one of the coefficients here is 1. So it really means whichever one we have the least amount of reactant of, that's the most amount in terms of moles of product that we can make. It's exactly a 1-for-1 exchange here. So if 2.4 moles of this, since there were 4 particles in that picture, and there it says each one's 0.6 moles, since there were 4 particles in that picture, there's 2.4 moles of this, and then for this one there were 3 calcium ones, which is giving us 0.60 moles. Each one's 0.60 moles, so that's 1.8 moles. So that means I got 2.4 moles of this and 1.8 moles of this one, which means since they react in a 1-to-1 ratio, this is the limiting reactant, which means I can also only make 1.8 moles of the product here, COOH2. And so anything that's not that immediately, right, is going to get crossed off as a possible answer choice. Then, to get a mass of it, we would just need to multiply times the molar mass, which comes out like 167.31 something grams. So it's got to be this one is the correct answer. Okay, another precipitate question. SROH2 plus FeSO4. So we're swapping out the 2 metals here, right? We're switching them around. And so what we're going to end up with, okay, strontium is a +2 charge. Sulfate is a -2 charge, okay, so that's just a 1-to-1 in terms of how that compound is formed. Go ahead and erase that. And then the other one, Fe in this instance, because it is bonded to a sulfate ion, is a +2 charge. And it's being bound now to hydroxide ions, which are -1. So that means I need 2 hydroxide ions for that, so my formula should look like that, okay? So then what we do is we come over here, and we're going to see what precipitate would form in this situation. Well, SR does not have a rule, but SO4 does have a rule. It says all sulfates are soluble except for those of barium, lead, calcium, and strontium, which would mean that this would be insoluble, right? Whoops, I don't want to do that. I don't want to do here. Here we go. Go back again. There we are. So it's insoluble, so this one should be a solid plus FeOH2. Well, there's no rules here on iron, but there is a rule on hydroxide, and they are insoluble. So both of these, actually, the way that this works out, are insoluble, so they're both solids, actually. I said that wrong. So that should actually have been both of them in this particular problem. Okay, question 22. If something is insoluble, that means that it's a solid, right? So it's very reactive with acids. Nope, doesn't mean that. It's very reactive with bases. Nope, doesn't mean that. It will dissolve in water. Nope, it will not dissolve in water. So there's our answer there for question 22. Okay, question 23. This is asking about a single replacement reaction, which means you need to look at the activity series. Okay, that purple sheet with the list of metals from top to bottom. Okay, not the solubility rules, the ion sheet, not the ion sheet, the activity series. And so what we're going to look at here is, does zinc replace sodium? Remember, if this is element A and this is element B, we look to see, is A above B? The answer here is no, it's not, so this means that nothing is going to happen. So this one is no reaction, okay, based off of the activity series. Okay, and this problem here is going to deal with the solubility rules, so let me pull those up. Okay, so we want to see what's going to form, so I'm just going to swap out my positively charged ions. Okay, we're going to end up with potassium mixed with hydroxide, so that's a +1 ion and a -1 ion, so it's just one of each. I'm going to rewrite that, though, because that's kind of messy looking. Okay, KOH plus, and then now I'm mixing the ammonium with the perchlorate ion, so I end up with NH4ClO4. And when I go over here to look at the rules, hydroxides are insoluble except for 1A metals. Well, this is a 1A metal, so this is soluble, which means it is aqueous. Okay, and the second one here, ammonium, I don't know why this one, there is down here at the bottom. Ammonium, all ammonium compounds are soluble all the time, no matter what, so they are both aqueous. So really, if everything starts aqueous and everything ends aqueous, nothing ever actually happened. No reaction occurred, so problem 24 should have been no reaction. Okay, and then simply put here for question 25, since nothing happened and everything just stayed in solution as ions, nothing occurred, so all ions are spectator ions. No reaction happened, no precipitate formed, so we end up with all spectator ions. Okay, if you have a particular question on anything from this test, or how to use the rules, or how to use the activity series, just either put your comment in the discussion board or shoot me an email and I'll get back to you. Again, you guys will take this on Tuesday. Thanks.